Okay, hello everyone. Welcome to the live session of the Future Learn course Mystery of the Universe. Today we have a special activity. First of all, can you hear me well? Can you hear me okay?
Yes. Yes.
Okay, good. Today we have a special activity interview with an astronomy student. Today we have our student Jasper from Philippines. Hello Jasper,
Hello, Kamusta?
how are
Hello.
you today?
I'm okay. I'm feeling great right now.
Okay. So Jasper is actually a student from Philippines, and then currently working on a research topic about the origin of the first radio burst, which Jasper will explain in a minute. And then today we can ask Jasper whatever questions we want to ask. So Jasper will answer in student viewpoint, not in teacher's viewpoint like myself. By the way, I am Tomo. I'm the teacher of the this course, Mystery of the Universe. Today, also, we have a special guest, Professor Hashimoto. Professor Hashimoto is actually an expert with first radio burst. Hello, Tetsuya-san. Professor Tetsuya Hashimoto is an
Uh,
expert on FRB and actually direct supervisor of Jasper in Taiwan. So so we have international members here. I think we want to hear about Taiwan's astronomy research, how it's that, and also Jasper is in Philippines. So how about Philippines research, astronomy research situation? What kind of situation is this? So we can ask various many questions. Hope we will have enjoyable moment today. Okay, so maybe let's get started. So first, Jasper, can you introduce yourself a little bit?
allow me to share my screen first.
Sure.
Okay, so can you see my screen?
Not yet.
Hmm. Can you see it now?
Mm, yes, we can see
Oh,
now.
okay. So as you can see, okay, so my name is Jordan Jasper Raquel. So I am from the Philippines. Okay, so as you can see, that's
Mhm.
my graduation photo with my graduation gown.
Looking very nice.
Yeah, thank you. And then, who am I? So, I am a graduate of astronomy from the Rizal Technological University here in the Philippines. So, I am introduced to the group of Professor Tomo and Professor Tatsuya through an internship project that we have here in the Philippines or as part of our curriculum. So, I am a former intern or summer student of Professor Tatsuya Hashimoto from NTHU. So basically, I'm a member of their cosmology group, and the focus of my research is about FRB classification and machine learning.
Okay.
So yeah, so the focus of my research is about FRBs. So FRBs, scientifically speaking, are known as the bright millisecond duration flashes of extragalactic origin. So in simplest terms, you can think of them as a very short light flash in the sky. So they're like stars, but we don't know what they really are. So that's the beauty of studying FRBs. We don't know what they are. Yeah,
Mm.
and that's the focus of my research.
Oh, Jasper. Oh, very short. You said, but how short is it?
It's about in millisecond time. Okay, yeah.
Okay. Millisecond is one thousandth of a second, right?
Yes. If you divide 1 second into 1,000, yeah, you will
Okay.
find. Yeah.
Okay. I mean, we don't know the origin. Why this
Yes.
is happening?
Yeah. We don't know what they are really.
Hmm. So you want to find out the origin of the first radio burst?
Yeah. Basically, that's the grand goal of studying FRBs. We want to know what they are or
Hmm.
if they are all the same because as we know, there are different types of FRBs. Some are known to repeat and some are known to have not to repeat. Okay, so we want to know, we want to see whether they are basically the same, they belong to the same group, or they have the same, what we call in astronomy as progenitors. Yeah.
Mm. Mm. Very interesting. So
Yes.
did you find out the origin yet?
Well, not yet, but hopefully we will.
Okay, okay, okay. So for any questions about Jasper and the fast radio burst, his research topic? I forgot to mention, but any questions or any time are welcome. Please don't forget, don't hesitate to interrupt us. Okay, so Jasper, may I ask how did you get interested in astronomy?
So I got interested in astronomy because when I was younger, I found this astronomy textbook, and I have seen these beautiful pictures of the night sky and
Mm,
basically what's beyond the earth. So
mm,
what's beyond the sky. So it's very fascinating and mind-boggling to think that there are these things that larger than us, but we can't see them. Yeah.
mm.
So that's one of the things that enamored me into astronomy, something like that. Yeah.
Right, right, right. I completely agree. I myself is like that too. There are so many unknown things in the universe, including this fast radio bursts. So it's interesting to figure out what's going on in the universe. How about Professor Hashimoto? How did you get interested in astronomy?
Yeah, it might be boring answer. Actually, my case is almost the same. Actually,
Mhm.
I clearly remember that in Japan they have sometimes a TV program
Okay.
showing the beautiful astronomy images taken by the Hubble Space Telescope.
Right, right.
That amazed me a lot. Then
Mm.
that was the time that I decided to do astronomy.
Oh,
For myself, actually, that's one reason. Then
okay.
another reason is actually in my hometown, there is a small telescope. There is an
Oh,
observatory. So
mm,
therefore, maybe that's these two things are
mm.
probably the reason why I want started to do astronomy.
Oh, wonderful, wonderful. So Jasper, you started working with Professor Hashimoto, right? So
Yes.
how did you find Professor Hashimoto? How did your research team started?
Um, Professor Hashimoto was introduced to me by a common friend. His name is Mr. Daryl Joe Santos, and
Ah,
yes,
he was my student. Yes.
yes, yeah. He
Ah,
told me that he is your former student in
mhm.
NTHU, and
Right.
we got to know each other here in the Philippines. And he introduced me to Professor Hashimoto to do some research projects.
That's wonderful connection. This Da Santos was my student previously at National Tsinghua University, and he was doing a research on black holes. And then, he was also from Philippines, and then he and Jasper were friends, and they introduced our research group. This is a very good way to expand our research group, I think. Hmm. And now, Jasper, then after knowing Professor Hashimoto, how did you get interested in this fast radio burst?
Uh, can you repeat that for me?
Yeah, how did you get interested in fast radio burst? Why did
Oh,
you choose this research in
yeah.
particular?
Yeah, so I got interested in doing fast rate reverse because first, we still don't know what they are. So there are a lot of possible answers that we can get
Hmm.
from studying them. However, I also got interested in doing FRBs because majority of the papers that I have read about them uses what we call as machine learning. So,
Machine
uh,
learning. Okay.
yeah, so traditionally, astronomers study unknown phenomena by observing them extensively. Yeah, so
Okay.
they observe them repeatedly and repeatedly over a span of very long time to see
Hmm,
whether they can they can come up with something new
hmm,
to really understand what's that about. And
hmm,
However, nowadays we can now use machine learning. So what is machine learning? So machine learning can be better explained by using a scenario. So for example, if we have these pictures of stars and we want to really understand what makes a star, something like that. Okay,
Mhm.
so we give some training data to a certain machine because machine are better at repeated uh, processes. So if we want to do something repeatedly, we ask the machine to do it. Okay,
Mhm.
so we give the machine some training data. For example, as you can see over here, there are four pictures of physical stars, not the star shape. Okay, so we give them to the machine and we allow the machine to learn them. Okay, so the machine will try to find patterns, something like that, and it will come up with a rule. Basically, for example, the machine found out that stars are yellow. Okay, something like that. So
Okay.
if you give it a test data, so if you give a test data to the machine, and it follows the rule that all stars are yellow, then
Mhm.
it will assign automatically to these images that are yellow, they will name it as stars or something
Mhm.
like that. Yeah. So that's how machine learning works. It's how similar to our mind works, basically. So we want to learn something, we do it repeatedly until we have a perfect knowledge of what it is.
Oh. So if you first teach machine which one is the star among test data, and then when once machine has learned how to do this, now machine can do it by himself. Is that what you're saying? Is that correct understanding?
Yes, yes, yeah, that's correct.
Oh, very interesting, very interesting. And how do you use this machine learning for your research?
So
Mhm.
for my research, so basically we got a data
Okay.
so from FAST. So this is the FAST telescope. So you can see there's a
Oh, what?
description.
This is a huge telescope, isn't it?
Yes, this is a very large telescope. Basically, right now this is the largest single dish radio telescope in the world. Okay, so as you can see in the
How big
text,
is it? Yeah.
hmm,
How big is
uh,
this?
uh basically it's 500 meter. Yeah.
Ah, okay. So its name states itself. Okay.
Yes. So it's FAST stands for 500-meter aperture spherical telescope.
Oh,
So yeah, this radio telescope is found in China. So it was
okay.
commissioned in yeah, it was commissioned about 6 years ago, and it still holds the record for the largest single dish radio telescope in the world. Okay, so
Okay.
yeah, so in our research, we use the data collected by FAST and we try to do machine learning with it. So, interestingly, the text on the left of this image is produced by a machine learning chatbot. Yeah, as you can see, it is produced by ChatGPT. Yeah,
You
so that's
didn't write these sentences?
yeah. I didn't write that. So, uh, basically, as you can see, machine learning can be used in sorts of ways. But in our purposes, we use it for astronomy to study FRBs. Yeah.
That's amazing. When I read this, it reads natural. It doesn't look like it's written by a machine.
Yes. So,
Yeah.
yeah, so that's the power of machine learning because machine learning can learn many things by doing those things repeatedly and by learning what's wrong from what's right.
Ah, that's very very interesting.
Yes. So to continue about my research,
Okay, okay. Please go ahead.
so
Yes.
yeah, so basically this is the general idea of the study that we conducted. So it looks very much linear, but I assure you, it's not that very linear to see or to do even.
Okay.
Okay. So our general idea is to get the FRB data for certain FRB from FAST, and we
Okay.
apply it to machine learning, subject it to machine learning, and then from the machine learns what this data is all about, and then we find what we call a FRB classification. Okay, so
Mm,
we classify what these FRBs are.
mm.
Okay. So if you want to know more what's in between or what this arrow stands for, you can read our paper after it is published.
You already have written a paper?
Yes, we did wrote a paper
Oh,
about FRBs.
amazing, amazing. Hey, Jasper, may I ask, which grade are you? you are still undergrad student, aren't you?
Yes, I have just graduated from my undergrad.
Ah, right. I saw the picture. So you
Yes,
just finished your undergrad, and then you already have a paper.
yes.
Oh, oh, that's amazing. Well, about how long did it take for you to write this paper?
Uh, the time it took me to write this paper and to submit it to the uh, journal is it took me at least 1 year. Yeah, it took me at least
Okay,
1 year.
okay. Still take a long time to write a paper, I guess.
Yes.
Hmm.
Uh,
So,
I
mm,
I would just like to add that it is my first time to submit in such a journal. Yeah, because I've submitted in a pretty much prestigious journal.
it must be because you're so young, right? You just graduated from a university, so that's amazing.
Yeah.
My first paper was when I submitted my first paper. I was already a master student when I was young, many years ago when I was young. So it's amazing. You're an undergrad student and then you already submitted a paper. That's amazing.
Yeah, it's pretty much overwhelming at some point.
Mm. So um, your paper you use machine to classify first radio bursts. Is that
Y-
how you use machine?
yes, we asked the machine to do the task of classifying these FRBs for us.
Okay, using data from 500-meter telescope.
Yes.
Hmm. So may I ask, what was the result? Did
Uh,
the machine be well? Yes.
yes, we did find that the machine is very good at classifying these things because the data is quite large. If
Okay.
you think about it, and a person such as myself cannot do it physically, like manually. I cannot classify them based on multiple features of data. Yeah, but the
Oh,
machine does
okay.
it well. Yeah,
Hmm.
so the machine did great.
Okay. So, machine classified into several groups,
Yes.
several different.
So in our classification, we found that uh, the FRB data that we had can be classified into four groups, but in the
Oh, okay.
literature, yeah,
Hmm.
but in the literature, there are only two known groups. So basically,
So,
we found an extra two classific groups or
so you
subgroups.
found two new groups.
Yes,
Okay. Oh, so those radio bursts in different groups are different somehow, right?
yes, they have some difference in physics.
Oh, so maybe there are different physical origins.
Yes, that's
Mm,
what we think, but
mm.
we cannot uh, really pin it down because we don't have that much uh, complete knowledge, as we say. We don't
Okay.
have complete knowledge about it.
It may be different, but difficult. But could you tell us how different these groups are? Some are bright, some are faint, something like that. Some are long, or some groups are short, something like that. Or it's not that simple.
Yes, it's not that simple because somehow in a certain range of values, okay, for example, if you classify them as bright, we cannot really say that one group is particularly much brighter than the other because uh, the
Okay.
study employed a multiple as we can call this as like multivariate, something like that. We classify them as using different parameters simultaneously. So basically, we classify it as bright and as long and as uh, short
Okay.
simultaneously. So we cannot separate one feature from another.
But machine can do it. Oh,
Yes, the machine can do it.
oh, that's amazing. That's amazing. Oh, Professor Hashimoto, do you want to add something? 'Cause,
Yeah. Actually, I wanted to add a little bit more.
okay.
So Jasper is using this fast radio burst which is coming from the same astrophysical source. Say,
Okay.
it is already known that, okay, these FRBs are coming from this source. We already identified, the same source. So therefore, naively speaking, we don't expect many different types of FRBs coming from the same source because the source
Right.
but somehow, it is my surprise that Jasper found at least two different groups from the same source. It is really not expected so far. This is really new and then really exciting part. So therefore, we may find some different physical mechanisms for the FRBs, even for the same source. There might be different mechanisms to make FRBs. This is really, I think, exciting part of what Jasper found.
Wow. Oh, two new mechanisms. That sounds really amazing. Maybe you should call New York Times and then let them know there's a new discovery.
Yeah.
I think that's really great. So maybe I can ask first Hashimoto one more question. I have an impression Jasper is really smart. What's your impression about him?
Yeah, actually, so maybe I also know about Daryl Joe Santos, who is a
Right.
and then Daryl was also smart person. So therefore, I was really surprised to see Jasper really writing papers and then doing machine learning. I didn't teach many things. Actually, he really did his research by himself. So we just decided a direction, and then Jasper was really able to do this by himself. Therefore, I feel that Jasper is really genius person.
Really? Yes.
I was just lucky to be able to work with Jasper. So thank you very much for this opportunity.
Yeah, I'm also amazed that Jasper is an undergrad, not a graduate student.
Not many undergrad students can write papers. Therefore, I feel that I'm really happy. I'm lucky.
Very nice. But then to publish a paper in such a quick time, the professor must be also good, no, Jasper? So
Yes,
Jasper,
I agree.
what's your experience working with Professor Hashimoto?
Yeah, so working with him is very much, it's easy. Yeah, you can call it easy because he knows a lot of things and can point me to the direction that I need to be. Yeah, and also uh, he's very hands-on on teaching his students and guiding his students on doing things like research and somehow like the basic studying of these unknown phenomena.
Sounds very nice. How about the research experience itself? Because usually undergrad students take classes at school, right? And then you have exams or reports or something like that. But I think the research experience is probably very different from usual taking classes. So, what's your impression about that? Did you like it?
Yes, very much like doing this research project because it's not that easy, but it's not that too hard to do because you have a lot of people that can help you to do things and to learn new things as well. And also doing schoolwork, it's not much of a burden because basically you have been a student all your life. So doing
That's
this,
good. That's the important part. So
yeah,
you finished most of the research, until the third grade, right?
Yes.
So in the fourth grade, you had some time to do research.
Yes, we do
Oh,
have that.
that's okay. I see. That's your secret. Okay. Oh, that's important. Because I see many students here. I also see many students in my university, Tsinghua University, and then most of the undergrad students are busy with classes and then exams and these things. So they have not much time for research. So that makes you different. Okay. Dear, any questions from audience? Do you have something? Okay. Okay. Here's a question from Miss One. Is a programming skill needed?
Is programming skill needed for research?
Um, okay, let me read it. Read the question. Hi, Jasper. I wonder if it is necessary to know programming well to study astronomy. Do you need to code a lot? That's a
I
good question.
Yeah, I think understanding the fundamentals of coding, especially in Python, because Python is the widely used programming language in astronomy. Knowing the fundamentals of Python is very very advantageous for any student who wants to do astronomy research. But I don't think that you need to learn the high level kind of Python to do astronomy research.
Okay. So the basic programming skill is needed, but
Yes.
it's not so high level.
Yeah, but yes, but still you need to practice as well. You still need to practice.
Okay, okay, okay. Is that okay, Miss One? Are there any other questions from audience about Jasper or Professor Hashimoto? Okay, okay, then okay. Go ahead, Professor Hashimoto.
Sorry, actually, I have a question to Jasper.
Okay.
Because you are really doing the research very well, therefore, I just wonder if in the future, so what kind of course, or what kind of things do you want to do? Do you want to become researcher in the future, or this is just a casual question about your future. So what do you want to do?
Uh, yes. So as of this moment, I think I just want to get my PhD first, and then from then on, I can plan to do either research or uh, teach other students as well.
I see. You want to go to the PhD?
Yes.
Okay.
So that
PhD in astronomy?
yeah, maybe astronomy, astrophysics, or cosmology. Yeah.
Oh, okay, okay. In that area anyway.
Yes. Oh, thank you very much.
Hmm.
So what kind of university do you plan to go?
I plan to go to the university that I think will be able to cater what I want to do by that time. And basically, the university will be able to support my research projects.
Hmm. So how about Taiwan? Do you wanna come to Taiwan?
Yes, I would love to. Yeah.
Oh, thank you very much.
Oh, that's an interesting question. So the research environment are different in different countries, right?
Yes.
So Jasper, may I ask what's what did it like to work environment, research environment in Taiwan?
So before I discuss what's the research environment in Taiwan, let me give a contrast on what's the research environment here in the Philippines.
Okay,
So
okay. Oh, that's a
yeah,
good point.
yeah,
Yes.
yeah. So the research environment here in our department, the professors here are very much active in research, so they
Mhm.
always push the students to do research in different yeah in different subfields of astronomy, and that's a good thing. And uh, however, the university as a whole, you don't conduct that much research compared to our department. So that's one good thing about our department, basically.
Okay.
So yeah, and that's one good similarity between the the physics department of NCHU
Mm,
and our department here in the Philippines. So when I conducted my online internship, so basically all my internship is through online. I experienced that the students, uh, other students, or the master students and PhD students in the cosmology group are very much active as well in their own respective projects. So basically, each and every one of us conduct different projects, and each and every one of us are being encouraged to do uh, well on these projects and
mm,
basically do a lot of things as well aside from that.
mm. That's good. That's good. How about the number of professors and students doing astronomy? Are there any difference between Taiwan and?
Yeah. So about the number of professors and students, I think the number of undergraduate students taking astronomy is uh, much more many here in the Philippines compared there in Taiwan, because I'm not quite sure about the number of enrollees in
Mm,
astronomy. Uh, but I think uh, there are certain similarities when it comes to the number of available professors.
mm. Okay, okay. From my own experience, well, there are certain differences. Um, so I have been in research Japan and then US and then also Europe, and then I'm based in Taiwan now. And then there are both, the advantage and then disadvantage in each region, I feel. For example, if you're doing astronomy, the access to the telescopes or large instruments, if you're located in an institute that owns big telescope, that's certainly an advantage. For example, before I was a researcher at the University of Hawaii, and the University of Hawaii have, has access to all the telescopes, all the big telescopes at Mauna Kea Observatory. And that was a huge advantage because even nowadays it's difficult to get telescope times, observing times of these gigantic telescopes, like Keck 10-meter telescope or Silver 8-meter telescope or Gemini 8-meter telescope. University of Hawaii, even students has access to all of these. And also, I was before at the Johns Hopkins University in US Baltimore, and then there I was with the Hubble Space Telescope's advanced camera team. So the team built a camera for Hubble Space Telescope. And then team has a guaranteed time to use this camera in advance to others. So we are able to use Hubble Space Telescope data in advance to others. So that was an advantage. That's one thing. Um, then in that sense, in also then students, in my opinion, students are little different. Um, for example, in Japan, students work very hard. You work a very long time, and there are a lot of um, people, lot of good smart students who can have a good score in exam. But in terms of how to say originality or uniqueness, they need to improve a little bit. Then when I was in US, there are a lot of students. A lot of students are very active. They ask a lot of questions, and they come up with very interesting ideas. There are a lot of active students in US, although their working time was shorter than Asian students. So that was an interesting contrast, I think. So in terms of telescope, there's an advantage to be in Taiwan to do fast radio burst research, right?
Yes.
So can you tell us a little bit about this new telescopes in Taiwan?
Yes. So this new telescope that is a collaborative project between universities in Taiwan is known as the BURST project. So basically, the main goal of this project is to discover a lot more FRBs than ever before and do science with it. So it would like to surpass what FAST can do. So that's the main goal of this project. And if you would like to know more about the technicalities of this project, I can go and find the paper here. So I have included the link. Yeah, here. So the
Go ahead. Sorry, Jasper. Go ahead.
yeah. So as you can see on the right side, so this is example of the burst antenna array that, or basically this is the burst telescope, a part of the burst telescope.
Is that you standing in the bottom? That's
Maybe,
a tiny person standing in the bottom.
maybe. I'm not sure.
Okay. Professor Hashimoto, maybe you want to, can you add more, something to add?
Thank you very much. Yeah, I didn't expect this actually. Thank you very much talking about this project. I believe this is a very unique project in the world. If we look at a similar project, actually this is the best in the world. Will be the best in the world because this telescope is trying to explore the unique place, say using the extremely wide field of view. So this telescope radio arrays can cover all the sky because FRBs are happening randomly in the sky. Therefore, we have to cover entire region of the sky. So in this sense, this telescope is really unique. So this can cover very wide field of view on sky to cover all the FRBs happening nearby the Earth. And then this uniqueness will continue even after the next largest radio telescope will start. Say it is square kilometer array, SKA. Even after SKA starts, there are science operation. So our Taiwan, this telescope will be still unique. So therefore, I hope that Taiwan can really lead this FRB science in future. So therefore, there is advantage for students to stay in Taiwan. So I mean to say.
Yeah, usually like a 500-meter telescope that Jasper introduced, it has a dish usually. And then if this type of telescope can only look at the direction that dish is facing, but instead, this new telescope that Professor Hashimoto is leading is antenna, so it can receive signal in any direction. So that's perfect because these fast radio bursts, we never know when it's going to happen and where it's going to happen. So you need to pay attention to all around the sky. So this telescope is perfect for fast radio bursts.
Exactly.
And then if you're in Taiwan, then of course, Professor Hashimoto is building this telescope. You can use the data from this burst telescope. So if you're in Taiwan, it's advantageous to do fast radio burst related science. I think. So maybe Jasper, you have one big reason to come to Taiwan. Would you
Yeah,
consider?
yeah, maybe one day.
Oh, Jasper, here's a question from the audience from Tom. Hi Jasper, how do you maintain the balance between class and research? This is important question, I think.
Yeah. So basically, what I do is that I weigh my options on which I do, on which comes first. For example, if the uh, if the classes wants me to do some project, something like that, because that comes first, basically, because I need to
Okay,
graduate as well.
right.
However, if it is not that urgent, I can do the research first.
Sorry. So if class has a homework or something, then that's first, and then you do research data.
Yes. So it depends on the urgency of the matter. Yeah.
Okay, but then research never has a deadline, right? Research
Yes.
is something, it's not a homework, so there's no deadline or grade or something.
Yes. But it also don't. It also doesn't stop. Like you still do it every day. It
Ah,
is a continuous job. Yeah.
oh, that's good. That's good. Oh. That's a good answer from a good student, I think, because many of my students are like that. Oh, professor, I'm busy with classes. I have final exams. I have homework, and then that's my typical of my student during the semester. And then when semester ends, right? And then soon we go into a winter break, right? And then winter break, okay. So you're busy with classes now, and then so you're going to do research in a winter break, and I don't know, professor, winter vacation. I need to go back from my hometown, and we have to celebrate New Year's party, and then so I'm busy. When I going to research, that's typical of my students. When undergrad. That's interesting. Okay.
Tomo-san, I have a comment.
Sure.
I think Tomo-san's undergrad students are still doing very well. I understand they are very busy, but I can observe that they are still active in research. Therefore, I think they are doing well too.
Okay. How about your student then?
For my students too. Actually, I don't have undergrad student yet in NCHU. Yeah.
Oh,
I
okay, okay.
actually here.
Oh,
Yeah,
I want, I want to ask Professor Hashimoto too. So, you graduated from Japan, right? You got PhD in Japan, right?
yes.
But then now you work in Taiwan, right? So how do you compare research environment in Japan and here?
It's actually difficult question to me. I think
Hmm.
I don't know, but in Taiwan, I feel that more students are aggressive. I mean,
Oh.
that's my impression.
Hmm.
So actually, when I was staying in Japan, actually they are kind of okay to go to stay in Japan. And then I didn't see many students trying to go to abroad, say, for example, as Tomo-san mentioned, say, John Hopkins or Stanford, any other famous universities.
Hmm.
I didn't, including myself actually,
Hmm.
I didn't see many students who are trying to go to abroad universities during their master and PhD in Japan.
Hmm.
But after coming to Taiwan, I see actually relatively more students trying to go to better university, more other universities in the world. So
Oh.
therefore, I feel that Taiwanese students say more active,
Oh.
try to go to foreign universities. That's my impression. Then actually, I think this works better in astronomy because
Hmm.
astronomy is it should be international. Yeah,
Hmm.
I really like this point in Taiwan.
Hmm. Yeah, I completely agree. Many Taiwanese students, try to go abroad when they are young. Sometimes they go to master degrees abroad, PhD degrees abroad, and then it's very good for sorry for young students to get international experience. I think that's very good. And then sometimes one of my previous students, maybe you guys know, Tiger, who actually took master here and then went PhD to Johns Hopkins University. And then there he actually started this summer and then immediately used Hubble Space Telescope data to write a paper, because at Johns Hopkins, many people are working on Hubble Space Telescope data. So that is one very good
I think
example.
JWST too. No?
Sorry, not Hubble Space Telescope, James Webb Space Telescope. Sorry. I'm from an old generation. Nowadays, Space Telescope is JWST. That's Hubble researchers. I was doing Hubble research. Nowadays, JWST. Oh, okay. In Taiwan, we are doing research with JWST too, James Webb Space Telescope too. Okay, so got confused. Okay, now, Jasper, do you have? Oh, okay. Now, Jasper, you are the main guest today. But do you have any questions to ask to Professor Hashimoto or myself?
Actually, I don't have any question right now because, yeah, I think everything is very much clear to me.
Okay. Good. Okay. Any more questions from audience? Okay. So, okay. How about Mr. Simon Hall? Do you have any question?
Hello.
Well, actually, Simon was my previous student, so thank you for joining us.
Yeah, thank you. It's my pleasure to join this meeting. So I have a question to Jasper.
Okay.
How do you compare the professors in maybe Taiwan and the Philippines?
Oh, that's a good question.
Yeah, in any aspects. How do you feel?
How do you compare professors in Taiwan and professors in Philippines, right?
Yep.
Yeah. So the professors here in the Philippines are, like I shown before. Let me go back to that slide before. So as you can see here in my department, in our department, the faculty members are very much young. Yeah. They are very young and they are very much vigorous when it comes to doing research. So they are very much achievers, as you can say. So they want to achieve many things, something like that. And same goes with the professors here in Taiwan. Yeah. And I find Professor Hashimoto and Professor Tomo as well as those kinds of professors that pushes you to do things.
So you like the professors in Taiwan or Philippines better?
I think there is no better professors in some sort of way. Yeah, I like them all. Yeah, that's the bottom line there. I like all of my professors.
That's a good answer. Thank
Good
you.
answer. Simon, I also want to ask you. So you are in Australia now. So
Right.
how do you compare research environment in Australia and Taiwan?
So I think Australia is very similar to the US environment that Professor Tomo mentioned. The students here, they ask a lot of questions compared to Taiwan students. So in the colloquium in Taiwan, basically you don't see students asking questions, just professors doing it.
Right.
And in those conferences of colloquium in Australia, you can see students asking a lot of questions. Sometimes you don't have time to ask questions because they ask a lot already. And also you can see variety of different people here studying astronomy in Australia. Like you can see Asian people, you can see white people, and actually sometimes you can see there are difference between their, how to say, their ways to work. Like Asian people, I think they are more shy, that they tend to ask less questions than white people. I think that is also this is due to the environment they are growing up. But yeah, maybe the Asian culture didn't teach us to ask questions, but the white people, they have a different growing environment that teaches them to ask more questions.
That's I feel the same way. When I was in US, I felt in the same way. In US, students ask many questions.
Right.
I think it depends on the personality of people. Some people are shy and some people are more open. But in terms of research, I think it's good to ask questions, because often when we ask questions, we learn something new. And then when ask questions, we start discussions, and then sometimes we have a new idea. So in that sense, Taiwanese students are a little bit shy, but that's something Taiwanese students could improve, I think.
Right.
Because, often when we are doing research, we have a new idea through discussion. We start asking questions, what about this, why this is happening, and that's where we come up with new idea. It's very rare people come up with a new idea by yourself, like when you're thinking about problem by yourself and come up with new solution. That's, I think, very rare. When, for example, I come up with new idea sometimes when I'm explaining students. Even when students ask questions, sometimes I even at the beginning I feel, oh, this is a basic question, and then I start explaining, and then sometimes oh, this idea can be used in another research or something like that. So I think discussion part is important. So in that sense, in the future, I want to, I want to create a class or research environment where people can ask questions easily to each other. It's one of the reasons when some student calls me professor, then I say, no, please don't call me professor. Please call me Tomo, but my first name, because we should be even as a researcher. Sometimes students have a good idea, sometimes professors make mistakes. So it's important we have a flat relation to frankly discuss these kind of things. So that's one thing I tell students all the time. Okay, any other question from audience?
Tomo-san, this is not a question, but I have a little bit things to say.
Okay.
So, Actually, thanks to this connection between Jasper and Taiwan, actually, Jasper University, these are technological university. So
Yes.
they invited me to provide invited to speech or even for the talk about career in astronomy.
Oh,
So,
that's very interesting.
yeah, in the past, I had the opportunity to share my previous experience with in Philippines. So
Yes.
therefore, I really want to say thank you very much. I really appreciate this opportunity. So therefore, I want to continue this connection so between Taiwan and the Philippines. So, so thank you very much.
Thank you very much as well.
Yes. Then I hope Tomo-san may be invited next time. I don't know.
Maybe we can try.
No, they are so they ask so many things actually. I think when I gave a talk, I feel that Taiwanese students are probably more shy.
Oh, that's good. That's good.
Philippines, they ask a lot actually to me.
Are they interested in astronomy, or are they interested in Taiwan, or what are their questions?
Questions one, when I gave a science talk, it was about science basically. But when I gave my experiences, then it was really about my personal things or
Okay.
opinion, something like that.
Very nice, very nice. I hope there are more and more interactions between Philippines and Taiwan.
Yeah, I hope so.
So far, students from Philippines that I have worked with are all very good, very smart. There might be a selection effect here, but they are all smart and then very good. So yeah, I also feel the same way. It'd be very good to keep good relation with Philippines. With Jasper, are all the Philippine students genius? So far, all the students I observed are very smart.
I'm not sure about that.
Okay. Well, there may be, selection effect that because those smart people are more open-minded and they want to look for international or go overseas, something like that. Maybe that's that kind of effect. Maybe we might there might be. Okay, then Jasper, I have one more question. I was looking at your slides and I saw that you want to travel around the world. So, where do you want to travel, and then what do you want to do?
Well, yeah. So that's one of my goals. So basically, I want to travel the world. So, and one of the places I would love to go to is the country called Bhutan, if you know that place.
Bhutan. Oh,
Yeah.
Asian country, right?
Yeah, it's an Asian country. So in that country, they're basically they have negative carbon emission, basically. So the air is very much clean there.
Oh.
Yeah, so basically, they have different kind of air. So maybe that will affect my health, something like that.
Oh.
So that's one of the places I would love to go to.
Oh. It's basically that very high country, right? Altitude is very high, no?
Yes, that's one of those things as well. It's cold and the air is very clean.
Oh, okay. Maybe it's a very good place to build a telescope, no?
Yes, I think so as well, because they don't have that much light pollution there as well, because they don't rely too much on coal emissions to produce energy.
Well, in In principle, it depends on the air, but in principle, if you go high up in a mountain, the water vapor are less and less. So the air is drier. Then it's better for observation.
Yes, that's one good thing. Yeah.
That's why
You don't.
a lot of observatories around the world are on high mountain because they are looking for dry air.
You don't need that much of adaptive optics, I think.
That's right. I don't know what the weather in the Bhutan look like. Even if high mountain, if it's snowing all the time, it's not very helpful. So, for example, in Hawaii, Mauna Kea Observatory, 300 days in 1 year are fine sky, blue sky. 300 days out of 365 days. So it's a very good place to build a telescope.
Are there no earthquakes there?
I'm sorry?
Are there no earthquakes there?
Oh, there are. That's a problem. Yes, because island of Hawaii is built by the volcano, right?
Yeah.
So volcanic earthquakes are there always. Small ones are always there. And then I think several years ago, there was a big one. And then the computers are falling off from the shelf or something like that. And then at that time, I think all the telescopes at the Mauna Kea Observatory stopped working for 1 month or something. So
are there any damages? Are there any damages to the telescope? Something like that.
Not major ones, just things are falling down, something like that. But it's not too bad because Mauna Kea Observatory, it's a sleeping volcano. The active one, it's Kilauea, it's more south. Mauna Kea, it's on the north of the island of Hawaii. So it's a more quiet area, but it's not dead volcano, it's sleeping volcano. So it might have earthquake or volcanic activity. There's no guarantee. So that's one worry, yes. But so far, that was the only one big earthquake, and then since then and before then, it has been quiet for many years. Well, one good thing to be an astronomer is you get to travel around the world.
Yeah, because I think that's one of the perks. Yeah.
Because the observatories and telescopes are all around the world, so you get to travel to those places. For example, 500-meter telescope is in China, right?
Yes.
And then Mauna Kea Observatory is in Hawaii. And then, a lot of telescopes are in Chile, high altitude Chile mountains in Chile. Another, La Palma Islands in Spain. It's also another, beautiful islands in Atlantic Ocean, La Palma Islands. There's an observatory. And also, that Kitt Peak Observatory, Arizona in US, in the desert, Rocky Mountains. Those places you get to travel. And also conferences. Because, astronomy is international research. There are a lot of international collaborations. So you get to conferences are everywhere around the world. So you get to travel a lot of places. Okay. Any other questions from audience? It's about time. So if you have questions, don't be shy. Say, what was it Simon was saying that Australian students ask many questions, so don't be shy. Okay, so Jasper, I have one final question. So, if you can achieve one thing, whatever you want, one thing in your life in the future, what do you want to achieve? You want to be a, I don't know, millionaire or space astronaut, or you want to be a president of the United States, or what do you want to do?
Basically, I want to get tenure.
Tenure?
Yeah.
You mean a
Is it
professor
easy?
in a university?
Yes, a
No,
tenure.
no, that's too easy.
Yeah. Is it too easy?
I think so, because there are thousands of professors around the world, no?
Mm.
Mm. But I agree. No, professors it's one of the good jobs, I think, because we do research, which is what we like, and then we get paid. So that's one good thing, I think.
Yes, that's very much the essence of doing it.
In Philippines or in Taiwan or
Maybe as of this moment, I still don't know where, but
wherever it's fine.
what? Yeah, anywhere is fine.
Okay, maybe in Bhutan. In Bhutan, it's
Yeah,
also
maybe.
possible.
Yeah, maybe. Maybe.
Okay, okay. Okay, thank you very much, Jasper. It's about time to finish. We heard a lot about you and then Philippines and Taiwan. That was, I think, it was very enjoyable moment. And thank you very much, Professor Hashimoto, for joining us. Good luck
Thank you.
with your telescope project first.
Thank you very much.
Yeah, we all are looking forward to that. And then thank you very much for everyone joining. Miss Wan, Tom, and then Leo and Simon. Thank you very much for joining. We gonna conclude today's session in a few minutes, but then this Future Land course is going to continue. So you're please welcome to join the course. And then we have 2 more live sessions afterwards. So tomorrow, actually, Jasper mentioned Dar Sanders. He's also from Philippines, but he's working now in Germany. He's going to join us, and then we're going to hear a lot about research in Germany. He's actually joining a big European, very large telescope project, so we can hear about that project. And then also later in February, we have a live session with Albina On. She's from Brunei. She's doing a research in Taiwan, but she's from Brunei. So we can hear about astronomy research in Brunei later in February. So, please stay tuned, and then see you hopefully again tomorrow with the live session with that. Okay, thank you very much, everyone. Thank you, Dar and Professor Hashimoto. Thank you very much, everyone. See you hopefully tomorrow. Thank you.
Bye. Thank you.
Okay,
Thank you.
bye-bye. Thank you, Jasper.
Thank you.
Bye.
Okay.